Okay, so the way to draw. So okay, let's start with a latch first.
When Montagny drew a flip flop, I was like, damn.
Yeah, because I missed the class where he first went over them. So
He drew him 3 times.
So the
Uh,
first thing you do to draw these is just draw NAND gates, not names.
nor.
Yeah, like this, one on top of the other, and then you put one input over here and one over here. The next input, you just do a cross like this, and that's how you draw it. Does it make
little blue drawing.
Oh,
See, the part about this that always got me was where do you start?
Where do you start?
just
Gates.
draw
Yeah, like
two
how do you
OR
determine
gates.
the outputs of the OR gates if they depend on one another's outputs?
Over here.
I would just draw like gates first and their outputs, and then loop them back around.
Yeah.
I'm
This.
confused.
You mean how to draw? Wait, what did you mean by that?
Like, how do you like determine like the outputs of like Q and Q bar if you need the output of the top gate to use on the bottom gate, or you need the output of the bottom gate to use on the top gate?
So that's
Because like
that.
the outputs are one of the inputs from the other gates, and they both cross each other. So like, how do you know where to start?
Also, flip your Qs.
Hey,
Q
what? Isn't it supposed to
Q
be
nuts on the
Q?
top.
Oh yeah, it is on top.
Not right.
Flip flop.
Yeah, they only look like that once you put them in the box design, because you flip them. Um, yeah, because for this you evaluate the outputs already given, so you would put the ones in and then you'd put them through the gate. That's what he's been teaching us so far.
Also, you need to remember that these gates, they are how can I say this? They are three-dimensional. They don't only exist on the paper, they also exist across time. So an output over here might not be the future state of the same gate. That's why
Yeah,
it's kind of.
that's the whole evaluation thing that he's
Yeah.
trying to, the QT plus one.
Uh-huh. That's why you need, yeah, you have that Q and a T, and then the Q T plus one, because these gates, they exist across time. They remember the past state, they past state. So that's why it's confused, seems confusing, but they, you need to understand that they exist in this manner, with time associated with them. Does it make sense?
Yeah.
I know it makes sense to you.
I'm sorry. I'll stop talking.
See, Riley already knows everything about computer architecture. He's
No,
like
not.
the
I would not say that, but uh, these aren't so bad.
So
Are
the
you
ones with
talking about
like the AND gates in front, that's for the D flip flop one?
The D has an inverter because you have to flip the inputs so that you have both of those values existing, which will cover that because you have to have SR and understand SR to get to D.
Okay, okay, yeah.
that's QT plus one, right?
Yeah, that's secondary, the one on the right.
Uh, flip flop.
not what I meant, but
Look up electronic.
Flip flop, yeah. You're just gonna get samples.
Bro, nothing about this class has anything to do with
It
like
has to
what
do
most
with
people
electric
want to
design and
do.
computer design.
No, like I'm saying, like what most people want to do in IT. This class has nothing to do with that.
It's the very basics of how a computer works. So it depends because IT is so broad is the problem.
Yeah, yeah, yeah. That's true.
So it really depends. Here, look
Like,
up digital electronics SR flip flop. Oh, that one's right there. That one's fine. Oh wait, why?
Why does it have it reversed? Oh, it's because the S is on the bottom.
yep.
Oh yeah, okay. Um, I guess you can use that one. I wonder if I could just throw you a clip art really quick if I could find one. Let me look it up.
The internship I got right now is like what would you like what most people like think of when they think of IT? Like I'm doing like internal IT for a company.
Probably like help desk and like server maintenance.
Yeah.
That's usually where you start.
System support specialist.
Yeah, something like that.
I don't remember the name of the person that asked how they work. Was it Logan?
Yeah, that was me.
Yeah, so this is how they behave. You see that they behave across time. So when you do a reset, the R stands for reset and the S stands for set. So when you do a set, you set the Q as true. And then when you do a reset, you set the not Q as true. So the inputs, they remember the previous state. So they have this behavior of memory, if you can see over here on the animation, if that makes sense.
Yeah, because before Professor started the lecture, he said that this relates to memory. So these devices are the very basics of how you store and recall data.
Mm-hmm.
Like you have to have these to have sequential circuits, which is the overview of the type of circuitry this is. Yeah, it's I tried to make an overview video, but then once we got to the clock part of the gates, I just lost where I was and ended the video. I may post it, but like I don't think it does a better job explaining it, just because to explain it you need to know where the issues lie, like where they're not understanding it. So I could still technically post it. I just don't think it'll do any more help though to anyone. So I might just do that though.
It was a very good one that I saw yesterday. I can find it.
Yeah, it's not giving you the good versions of it. It's giving you like I'm getting a lot of like the flipped versions.
This one he found right now is the right way.
Yeah, I don't think it really matters because I'm pretty sure we have it.
So
If
when I
anything,
do-
it's the logic from the character table that's that don't need to be explained.
okay, so if that makes sense, if
Oh, I
this
found one. Hold on.
send it. Can you send it?
It's in study group. Unless you mean like an animated one, but that Q with the apostrophe is still Q not. That mirrors what we were writing them like in class.
I don't see it animated.
Oh, is it
He
not
said it's
working?
not- yeah, it's not animated.
The original one was. Hold on.
I tried to find so my the first time I learned this, my professor showed us one of these animations that had both being true and how it got unpredictable. But I never could find one GIF like that.
Safeguarded secrets. The
Yes.
SR flip flop. But yeah. Alright, we should probably make the characteristic table for the SR gate, and then we can introduce the D gate. Because the D flip flop shows us trying to think of the what I'm trying to say. The D flip flop gets rid of the no change and undefined outputs.
Uh-huh.
So building off of this is probably the best way to do it. It takes a while though.
Let me see if I remember how to do this.
You just put 0, 1, 0, 1 for QT, and then you evaluate to put the next value in the bar there.
Like this, right?
You have to double up each binary value for the SR. It has to be 0, 0, 0, 0, and then 0, 1. You have to double your outputs so you could evaluate for each
Yeah, so
Q
you have
input
to,
changing.
Oh, I see. Hold on.
Yeah. I was like, why does it look so tiny?
You mean like these two, right?
um,
Like,
so you put 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1.
Like this, you mean?
No, just twice. So put 0, 0 for S and R,
like that. 0, 0.
and then
Okay,
another
okay,
time.
okay. Yeah, you just have to do double of it, basically.
Yeah, and then put 0 and then 1, because you evaluate it each time. No, sorry, for the QT, you want 0 and then 1 going down.
0 and then 1 over here.
No, going down. Because your QT plus 1 is your evaluated.
Mm-hmm. Oh, I see.
Yeah, and now you do 0, 1, and then 0, 1, and then 1. Yeah, you got it now.
Yeah, so you can see from each one.
Yeah, because you have to evaluate your SR. And then with the QT is 0 or 1. Because I was wondering, I'm like, why is it so tiny? There we go. And then you just copy paste 0, 1 because you have to evaluate it
0, 0,
for that.
And then they go like just like 0, 1, 0, 1, right?
Yeah.
Yeah,
0,
just
1, 0, 1.
yeah. You got it.
Stuff that we need to memorize. So okay, so we have S and R. They over here. There's 0 and 0. And then Q at this time is 0. So this over here is 0 and 0. So they all should be 0, right?
Q naught should be 1 because it's the opposite of Q. If that makes sense. Yeah, because logically speaking, your Q and your Q naught should have opposite values. So at the very beginning, Q naught should be 1, and then you evaluate it to see what changed. There you go.
Right. This is 1, and then this would evaluate to 1, and then gets inverted to 0, right?
Mm-hmm.
And then this over here would be 0 and 0, and so this is 0, and then this evaluates to 1. So this would be 1, right?
Yeah. No, that would be 0 because Q is going to be 0. Because
Yes.
your QT
Oh,
plus
so
1, yeah, is the new Q value.
So what goes here is just the Q. It's
Yeah,
always
it's only the Q. And then the undefined would only come up if your Q and your Q naught, the evaluation point, is the same number.
Mhm. So S and R are still 0, and then Q, the first Q is 1.
Mm-hmm.
And then this over here would be 1. So 0 and 1, this would give a 1, and then this becomes 0, and then this becomes 0, 0, and then this becomes 1. So Q is 1.
So it just flips.
Yeah,
It starts at a 0 or goes to a 1.
yeah, this thing over here flips.
So there's no change for those two evaluations. Because you
Why
put
did
a
he
0
have-
and a
Why
1.
did he put undefined then in class? When we went over
Undefined
this?
or 1, 1 at the
Oh,
bottom.
okay.
Yeah, we'll see those at the very end of this.
Okay, so S now.
No, I mean, he had ours for 0, 0. He had it as undefined.
He did?
No.
Yeah.
What?
Here, let me send the picture. Like, I literally copied exactly from like what he had on the board. It's like this table we're doing right now. Let me send a picture and put it in the study group.
Was that for the regular SR or is that for something else?
Yeah, it's SR.
Hmm? He must have flipped those around then. See ya.
Alright, see you later.
See,
Uh,
isn't
hmm?
because it's an AND gate?
Oh, yeah, because, yeah, okay, never mind. He flipped the logic, so those are AND gates in that point.
Okay.
I was confused because I'm like, I have that as well. Okay.
Okay,
I'm going to
yeah,
actually
that
write that in my notes now because I don't want to see that. And get
Yeah,
confused.
I didn't notice that either. Okay, that makes sense. Okay. Yeah, because I remember it was an exercise. He's like, oh, okay, this.
Mm-hmm.
Okay, I'm gonna show this to the video too so they can understand. Yeah, so if you use the NAND architecture, it's going to change what your undefined and your no change values are going to be. In the case though, we're using NOR, so it's going to be what we're doing here now. Yeah, thanks for pointing that out, because I'm like, what?
Yeah.
Yeah, I mean, we don't want other people's notes
Yeah,
screwing
that's
them
why I
up
had
too.
gotten confused, so.
I wouldn't even mess with NAND. That's so much evaluation.
0, 0,
Oh
or
no.
0, 0, and then this one would be 0. So this one is 0, and then these two are zeros.
Yeah.
So this becomes, both are 0, so this is 0, and then this becomes a 1.
Mm-hmm.
And here, 1, 1 and 0 becomes 0, and then this becomes a 1.
Yeah, so they're both one, so it's undefined.
So
Mm-hmm.
this is a contradiction over here. So yeah, that's why it's undefined.
Because Q and Q naught can not be the same numbers.
Mm-hmm.
They have to be opposites.
Yeah, so this over here is 1, and this is 1 as well. So this would be a contradiction. Make sense?
Yeah. We have to do the entire table though for the SR NOR implementation. Yeah, I would.
S is 0, R is 1.
I
and
would stick
Q-
with NOR just because that's what he's doing in class.
And then Q is going to be 0.
But that's the problem. If he tells us to, because he presented this in class, even if he didn't mention doesn't mention this on the study package, we have to know how to do this because
Yeah.
he did this.
Yeah.
He didn't mention anything, and then he put problems on the exam we didn't cover.
Yeah, I mean, technically we can do it. I mean, if we want to do that in the video, I guess we can.
Yeah, I feel like for now we should just focus on the OR gates and then
To keep it
maybe,
more concise, and then maybe have
Yeah.
notes in the Discord. I don't know.
because I feel like if you have a good understanding of the OR gates, learning the AND one is going to be much easier.
Yeah, it comes down to logic, the logic
Yeah.
gate design.
0, 0, so 0 or 0.
It's like technically we don't have to do this either, but we have to have a full table of either the NOR or NAND implementation so that we can put the D variable in.
Yeah.
So I would just stick with NOR.
Yeah, so 0, 1, and this is a 1, and then this is a 1, and then this becomes a 0, and then 0, and then 1, and then 0. This one's 0. So this.
Wait, hold on, wait. So 0 becomes a 1? Like when it goes past the NOR gate, it goes from 0 to 1, right? The S?
It depends on what your inputs are. So if you have an input of a 1 and a 0 into a NOR gate, that'll evaluate out to a 0. Just because of how NOR gates functionally work, it's a OR gate with an inverter at the end.
Okay.
Yeah, do you understand how that works though?
Kind of.
Yeah, I'd probably just draw it out. That's how a NOR gate looks if it's full gate.
Yeah, like not simplified version.
So if you do 1 and 0, it's going to output a 1, but then when you get to the NOR gate, the inverter, it's going to change to a 0.
Okay.
Yeah, so that's what those look like in their expanded form. However, you would not want to do that at all. That sucks.
Like a lot more complicated.
Yeah. I really want to. I think I'm gonna post the video. I'm gonna crop off the end of like where I just got confused, and I'm gonna post the video because I go over the architecture. Yeah, I'm gonna look at it and probably post it because some of it's a little helpful. And it wasn't too long, so I might just do that then.
So then let's continue. Let's finish this one. So this is 0, 1, and this is a 1.
Mm-hmm.
So here's a 1, and then this becomes a 1, this becomes a 0, 0, and 0, it's a 1, and then becomes a 0 over here. So this would be a contradiction, or no?
No, because you have to plug the 0 back in to make sure nothing changes.
Oh, over here, right?
Mm-hmm.
So 0 and 0, this would be 0, and this become a 1. Oh, I see.
Yeah.
And then the output would be, I wrote on top of stuff, and now I don't know. Would be 0.
Yeah, just 0. And that
Correct.
follows the entire rule of him saying if it's reset that's triggered, Q turns to a 0.
And then now we have set as true and reset as false. So Q 0, then this becomes 0, and then this becomes a 1, and then becomes 0. And then over here 0, 0, 0 becomes a 1, and then we have a 1 over here. This becomes a 1 as well, and then 0.
See how you're right.
So this is Q is 1.
Mm-hmm.
Next one, now this is 1. 1 and 1, 1, 0, 0 and 0, 0 becomes a 1. Then 1 over here again. 1 and 1, 1 becomes a 0. So 1.
Here's the fun ones.
Now we have we have 1 and 1. Then this is 0. So over here's a 0, and then 1 and 0, 1. And then this becomes a 0. And then over here becomes a 0. 0 and 1, 1. And then this becomes 0 and 1, 1. And then this becomes a 0. And then 0 and 1, 1, 1 becomes a 0. So not Q is 0 and Q is 0. This is a contradiction. Undefined.
I'm deaf.
Yeah, that's normally what you write it as.
Yeah.
I wouldn't try to stretch it out anyways, because those gates.
And then this is a 1. 1 and 1, 1 becomes 0. 0 and 1, 1 becomes a 0. And this becomes a 0, I guess. And then this becomes a 1. And then 0, same thing. This is a contradiction. So undeaf. Correct?
Yay.
Hey, we did it.
Now it's the fun part.
Now for this, so what I have researched, this is actually a latch.
Yeah.
This is not a flip-flop. A flip-flop needs to have a clock attached to it.
Yep.
Yeah, so that's then would be the D, where the D flop, whatever the heck. I don't even know what it's called.
That's a D flip flop, but if you
Is
put
that
a
when he
clock into the, you can still put a clock into the
Oh,
latch,
okay.
and it turns into a flip flop. However, I don't think it'll be working with
Yeah, 'cause
those.
the only one he showed the clock on was the one on
Yeah.
flip flop.
So to draw, so you guys feel comfortable drawing this, right?
Yeah, I can
Yeah.
draw that.
Yeah.
Yeah.
Okay. To draw a JK, I have a real hard time not reading these as just kidding flip flop.
Oh, you should probably add the the D latch onto here because the
Yeah.
D latch gets rid of the undefined and the no change parts of our characteristic table. So they're really helpful. You should probably it's literally just an inverter as your data input, but it removes the 0, 0, 1, 1 outputs and only leaves your 0, 1, or 1, 0. If you know what I'm talking about.
Let me see if I remember how to draw them. I don't remember.
I
how to
love the
draw
Minecraft one. It's so funny.
My God.
I was looking at it.
Oh my God.
flip flop Minecraft.
I'm excited for the frogs that they're adding in the update.
Why did that line up? The piston pushed it and the Discord noise went off.
Coincidence.
Coincidence. It's listening.
Let me see.
Yeah, it's that guy right there. It's that first one.
This one.
No, if you go back up,
Yeah.
it's that first guy there. It was the little inverter. Well, maybe not the AND gates. Never mind. Wait. No, because the AND gates have the clock attached to it. That's right. So that is right. Okay, this is confusing. Hold on. I could
Here,
probably.
I just sent the one from my notes. That's how you.
Oh, it's flipped.
Yeah, bruh.
Yeah, so in that case it has the clock, but
Yeah.
logical sense you don't really need the clock just to make it
Let me try
understandable.
To flip it. Why did it sound like that? It's so stupid.
So for the D flip flop, you would have the same thing.
Yeah,
it's
it's the same
basically
thing
the same thing. You just have to add the AND gates in front.
for the clock, and
Yeah.
then I mean, conceptual wise, you don't really need the clock to understand how the logic works, but the clock is there because it turns that into an actual flip flop.
Yeah, it's a regular.
It's
Hopefully it's the right way.
super annoying to.
And then you just have to add AND gates.
Yeah.
start.
And then the clock goes into, yeah. And then there's another input that's called D, which is your data. Yeah.
This would be S and R.
S and R wouldn't be that far out. S and R would be right before the NOR.
I don't know. That's how he drew it in class, so that's how I had it.
I mean, I guess, because if you have it after the inverter, it doesn't really make a difference.
Mm-hmm.
That's how he drew it in class.
Yeah, just make sure you put it after the inverter then.
Because it's the same drawing over here.
Yeah, that's... Yeah, as long as you... Because then before those, you would have the inverter, so that you get rid of your same number instances, which would give you a no change or an undefined. So, yeah, that's right. But just make sure you write the inverter behind it before those two. If that makes sense.
So this
That's
is
the JK flip flop.
no, this is the D flip flop.
The D flip flop.
D flip flop needs more to it. Could I just annotate, or are you gonna do it?
Yeah, sure.
Okay, so for D flip flop, you would also have this guy here. And that's because you would no longer have the instance of having both zeros or both ones, because if you put a 1 here, it's going to turn this into a 0, and this would be 1. Or if you have a 0, that'll give you a 1 or a 0 up here. And you can no longer have the same inputs anymore. And it gets rid of that part of the characteristic table where that was the case. So here, let me actually... Yeah, you can probably write it back. I had to get rid of my annotation, but hopefully that makes it hopefully that explains it a bit more.
I wish like you know it'd be great. What if like he just like on the test question we just had to draw the flip flops without like doing the chart and everything.
Mm,
I don't even know how he would use this in a test. Like, what would he even test this on?
he'll probably have you
Just to
draw it and then put the characteristic table, I'd imagine.
Okay.
But that's not even really testy. You just grab it from the notes.
That's what I'm saying.
Oh
Like,
yeah, true.
I
Like I
mean,
can just
he
literally
had on
copy
the
the
first
notes
one
for
with the
that.
truth tables, which were like,
Maybe he'll ask
yay.
you, why would you put a inverter at the beginning?
Maybe.
To have that like conceptual knowledge of like, yeah, if you have that, there's no longer the possibility of having 1100. But I I don't really see him doing that, honestly.
Do you think this next exam is going to be online or is it going to be in person?
Online, if he's being consistent.
Yeah, I feel like
But who knows?
yeah, it's probably going to be online. I think it's easier for him when it's
Yeah.
online.
Yep. So for whatever reason, I don't really know why it's called JK flip flop. My mind always corrects for just kidding flip flop.
JK.
Yeah.
So the JK. So it's to draw, it's the same thing. You just draw a regular flip flop. But remember that over here, you can extend this and then include this into an AND gate. And then this is the J, and this is the K. And then there's a...
Did he do
Yeah, I was just looking at my notes. He never drew a.
He never did.
Like, he only did a box form.
Yeah, that's what I just noticed that now. He only did box form JKs. So
Really?
yeah, that's
Okay,
oof.
so like,
That just looks really confusing. What the heck?
That's probably why
Yeah.
he didn't do it right away.
this is, yeah, this is the way to draw it. You just extend this and then you add to an AND gates, and then it becomes a JK flip flop. I don't know why the name changes. The name changes for some reason. And these are
Damn.
the types of flip flop. So this is a latch over here, and then this is a D flip flop. This is a JK flip flop.
Yeah.
Dang, I can't draw that JK flip flop.
I wouldn't yet, because he's only been drawing the box form.
Yeah, that's probably a reason why. Maybe, hopefully.
And real quick, can we do the box forms for all the flip flops?
Yeah, we should probably do that. I have it in my notes here. Should I just... Okay, you got it. Never mind. And I'm pretty sure he said he wanted us to draw the little inverter sign for the Q knot. The little this guy for Q knot.
Oh, yeah.
Yeah, so I
Oh,
would
I
still draw that. Because for the box designs, he has the Q's on top, the Q knots on the bottom, because he flips the
Yeah, that's what I was
outputs.
saying. Remember, you have to unbox form. You have to have the Q bar on the bottom.
Riley, do you know why some of the drawings has this triangle over here?
That's
for
the clock. The
Oh,
clock
okay.
equals triangle. So in that latch case, alright, so for class, he put the inverter on the bottom there in Q naught. And the top has just a regular with a Q, because what he did in class is he took this lead and put it there, and this lead put it there, and then turned it into box form.
So Q.
So you're just
Q-
flipping your outputs there.
Okay, so Q's at the top and then
Yeah.
not Q's at the bottom.
Yeah, in box form. Other way around, it's what we have there. It's super confusing, but
Okay.
yeah. And same thing for the D flip flop. Q's on the top, Q knots on the bottom. And then you have to add your data input with the clock.
And then these would be S and these would be R, right?
And you gotta add the clock.
He has
Yes,
the
sir.
clock, it's right there. It's a little triangle friend in the middle.
This is not included in over here.
Yeah, the D wouldn't be there because you put that with an inverter before you get to the actual box for the latch.
One.
Oh wait, go back up. I gotta re-see that again. Oh, hold on, wait, give me a second.
Yeah, for so the D flip flop, you still technically, like we said, we have our little friend here. Just keep that in mind.
Didn't he just write it as like, just instead of SR, he just put the D and that was it?
I mean, if you know to do that, yeah, you can still technically do it that way.
Okay.
Okay, thank you. I got it.
Right.
Oh, sorry, let me get rid of my. There we go.
Okay. And then for the last one, just have a big box. And then we'll have
I think he actually did write it that way with the D, the clock,
Yeah,
and the
he
Q
did.
and Q not.
Almost
Why does
all my examples have it like that?
it's so annoying? Why?
No, bro, I don't try to understand it. I just do.
does it have like that on the?
Yeah, he has it like yeah, it's not in my picture, but I should have just taken a picture of the whole page.
Yeah, Holly probably has it in there somewhere. I would think the notes above that. The notes above that one. Yeah. Which isn't really wrong. It's just I never see them that way.
I don't know. That's how he had
But-
it in class. I have mines like that as well.
Yeah, it's not wrong if you understand how that
So that's D.
works.
So that's for the D flip flop.
Yeah,
right?
the D would be just one of those boxes.
Oh, okay, so not with S and R. S and R is not in D.
Depends, but I guess for the professor's implementation, you just put the D, Q, Q not, and then the
Well,
clock.
like if you see from our top one, you kind of see how it's in the box form. Like the SR is within it.
Yeah,
It's just like
if you zoom
it's
in,
just like a simplified.
yeah, he's oversimplified that. If you go to that top area, it says that. Zoom in on that.
Whoa.
Yeah, that guy. Because you
Yeah,
can see
see
where
how
the
she has
box outline
yeah,
is.
the box around. That's why he just puts D and not the SR.
Then
Yeah.
it's over here.
It's very, yeah. So that'd be D. Now is JK fun time.
I find the box level way easier than everything else. So
Oh
this
yeah,
is-
of course. You just have
It's
to
much
know how
more
to do it
simple.
though. Because what I was showing you guys earlier, my homework technically from high school, it was box level, just so you can actually write it easier in a smaller amount of space. If you're an actual electric engineer or a computer engineer, you wouldn't do logic gate level just because of how many freaking logic gates you'd have in an entire computer system. You would take their box forms or the actual components those boxes are put into, if that makes sense.
Mhm.
Think of like a motherboard, how many logic gates are probably within just that one part alone, you know.
So
So
what about the JK flip flop? How does the box look for that?
no, we can get into that. That's that guy.
That's the JK.
Yeah, we didn't write it in gate form yet, if we'll even cover it, but that's the box form.